Hello everyone, this is Ashirwad here. Welcome to my YouTube channel, and in this video we'll discuss the most important token called as operators. So what an operator actually is, you can simply define it as an operator performs an operation on operand or operands. Okay, so let's see this with an example. When you write 10 plus 20, okay, of course you will get the result 30. So here this plus sign is an operator which is performing the addition operation on these two values. So in this case these two values are called as operands. Fine. Similarly you can write a plus b. So whatever is the value of a and whatever is the value of b will be added and you will get the result. So again this plus sign is acting as an operator, and a and b are acting as operands. Fine. Now there are two types of operators. First is called as unary operator and the second one is called as binary operator. Unary operator is an operator which performs an operation on only one operand, and binary operator is an operator that performs an operation on two operands. So in the example that I had given earlier, of course the plus sign there was acting as a binary operator because it was operating on two values. So let's discuss unary operator with the help of an example. So I have opened this idle window and here I am going to type some code. Let's say if a variable a has a value 10 and now for some reasons I want this 10 to be a negative value. Right now it's a positive value. So I can use this operator minus, which is of course a binary operator, but in this particular example it can act as a unary operator. How? You just write minus a here. So what it does is it converts the value of a into a negative number and stores it back to a. Okay, so when you see the result, or when you print a, you will see the value has been converted to a negative value. So this is unary operator. So there are various other unary operators in Python that you don't need to understand right now. As we go along you will come to know about them, but the most important thing is that you know the difference between unary operator and binary operator. Fine. Talking about binary operator, it's very simple. If a is 10, b is 20, you print a plus b, you get 30, and the plus sign here is a binary operator. Similarly, if you write a minus b, you get minus 10 as the value. So this minus is here, it is acting as a binary operator because it is operating on two operands. So there are some operators like this minus sign that act as unary operators sometimes, and the same operator can act as a binary operator sometimes. So it depends on what code you are writing. Fine. So let's move on to the category of operators. The first category is called as arithmetic operators, where you have this plus sign for addition, minus sign for subtraction, For multiplication you use asterisk sign. For division you have two operators. Okay, this one, the slash sign, is called as division or actual division, you can say. And there's one more, double slash sign, it is called as floor division. I will explain it later on. Then two asterisk sign, this is called as exponent operator, exponential operator, you can say. And then lastly there is modulus operator. What do you call it? Modulus operator. So let's discuss one by one all of these operators. You already know plus, minus, multiplication. So we'll start from this division operator. So when you write 5 divided by 2, it gives you 2.5, which is the actual value. Or for example, if you write 7 divided by 4, you get the actual value, which is in with a decimal point, you can say. So you can say whenever you use this single slash division or normal division or actual division, whatever you call it, you get the result in the form of a decimal number, even if the number is completely divisible. For example, if you write 10 divided by 5. Now here you have used the actual division, and 10 is fully divisible by 5, but even then you get the value as 2.0, not 2. So this is actual division. But for some reasons, if you don't want to bother about this decimal portion here, let me type the same code again. 7 floor division 4. Okay, so see what happens. You get the value 1. This is the value, is what you get. So floor division, what it does is it simply truncates, or it simply cuts the decimal portion from the actual division, and it gives you the integer portion of that result. One more example, if you write 5 floor division 2, you will get 2 here. Remember, it does not round off the value, it simply cuts out the decimal portion from the actual result. So that, don't get confused in that. So by these examples, I hope the difference between floor division and normal division is clear to you. So the next arithmetic operator we are taking is this exponent operator. How does it work? So the exponent operator, which you indicate, which you use with 2 asterisk sign. So if you write 2 exponent 3, that means it will calculate 2 to the power 3, which is of course 8. Fine. So if you want to calculate a to the power b, then you can use this operator for your purpose. So if in another example I write 5 exponent 3, you will get 125, which is equal to 5 to the power 3. So this is what this exponent operator does. The next operator is modulus operator. Modulus operator gives you remainder, remember. Okay, so when you use this in an example like 5 modulus 2, what should be the output? 2 to the 4, the remainder is 1, so you get 1 here. Similarly, if a number is completely divisible, then what value should you be getting? 0 because the remainder is 0 in this particular example. One interesting thing that you need to know about modulus operator, that whenever a smaller number appears in modulus operator, for example 3 modulus 5, since 3 is smaller than 5, then the result will always be the smaller number, which is 3 in this case. So any smaller number, for example 9 modulus 999, okay, in this case also you can simply say the result is going to be the smaller number 9. Something went wrong. I press enter key, so I'll type it again, 9 modulus 9999. You get the result 9, which is of course the smaller number in the operation. So this is what modulus operator does for you. Now when we are discussing operators, arithmetic operators, there is one very important concept you need to understand, that is called as priority of operators. So what do we mean by priority of operators? That which operator gets evaluated first when you have more than 2 operators in a statement. Okay, so let's see this with the help of an example, and before that let me tell you what priority does Python follow in evaluating operators. Okay, so listen to this carefully. The highest priority is given to the parentheses, the brackets. So whatever you write inside the brackets will be evaluated first. The second priority is given to the exponent operator. The third priority is given to division, floor division, modulus or multiplication. In fact, all 4 get same priority, but after this bracket and exponent. So whichever of these 4 comes first from left to right will be evaluated first, will be calculated first. Okay, we'll see this with the help of an example. It will be clear to you then. And then of course you have plus and minus. So for beginning you need to remember this order of priority in which Python evaluates statements. So let's see this thing with the help of an example. I have written a code here. Let me copy it in idle window and see for yourself. When you print A, you get the value 6. So let us solve this manually and check how are we getting this result 6. Okay, so here's the solution. When you write, so this is the statement. Okay, so what is evaluated first of all as per the priority I explained earlier? The bracket. So 10 plus 3 is evaluated first. So I have written 13 here and rest of the statement is written as it is. So this is one single complex expression in which you are seeing multiple operators, multiple arithmetic operators. So that is why the priority must be checked. Only then you will be able to solve these types of expression manually. So what have I done here is I have solved the bracket and I have written the rest as it is. The next statement we have is this. So in this statement you have this minus operator, the floor division, multiplication and the plus sign. So which of these 4 operators evaluated now? The floor division. Although the floor division and multiplication have same priority, but because floor division is appearing before multiplication, it will be evaluated first. So 8 floor division 4 is 2. So I have written 2 here and rest of the equation is written as it is. So now we have minus, multiplication and plus. So of course multiplication will be evaluated now. So 2 into 5 is 10. I have written here and rest is written as it is. So 13 minus 10 plus 3. Now because minus is appearing first, and because minus and plus they have same priority, minus is appearing first, so minus will be evaluated first. So 13 minus 10 is 3, and then plus 3 is written as it is, and finally you get the value 6. So this is how the priority is evaluated, and priority of operator is decided in a statement like this, where you have multiple arithmetic operators. So I hope the concept is clear to you. Now there is something called a shorthand notation of the operators. Okay, this shorthand notation can be very useful when you're writing code with many lines in it, and when you're performing calculations like plus, minus, multiplication, and so on. So how do you use shorthand notation? It's very simple. So if you write a is equal to 10, and now if you want to add 5 to the value of a, what will you write? A is equal to whatever a is plus 5. So when you print a, you get 15. It's very simple to understand. Same thing you can do with the help of shorthand notation. So how do we do it? I'm going to write all this code again so that you can understand. So let a be 10, and I want to add 5 to it. So what I write is a plus equal to 5, and when you print a, it gives you 15. So it's the same result. So plus equal to is a shorthand notation for this statement. So if you write a is equal to a plus 5, or simply a plus equal to 5, it's going to give you the same result. Okay, so when you practice the code, I would recommend you to use these shorthand notations as and when possible. Of course, it will work the same manner with minus sign, multiplication sign, division, floor division, and of course modulus sign. So for example, if you write a into equal to 5, so what should be the result? 75, because a was 15 earlier, so 5 is multiplied with 15 and you get the result 75. And don't forget that the result 75 here and 15 here, they are stored in variable a. So when you print a, it is no longer its previous value. It has been updated to the value 75. So don't get confused with this statement. Always remember, after performing the operation, it gives the result, or it stores the result back to the original variable. Okay, this is what you need to remember. So I hope the concept of shorthand notation is clear to you. Now another operator we need to discuss is called as relational operators. This is in fact the second category of operators. So what was the first one? First one was arithmetic, in which we saw plus, minus, multiplication, division, floor division, exponent, and modulus. Now we are talking about relational operators. So one thing that you need to remember from now on about relational operators is, first, they combine, in fact they compare two values. Okay, and the result is always true or false. Remember, we had talked about true and false earlier. Okay, so they are keywords. They represent a true value or false value. They are technically called as Boolean values or Boolean literals. So these are the 2 points that you need to remember about relational operators. So what are relational operators? You have less than, greater than, less than equals, greater than equals, not equals, and finally you have equal. So how do you use them in program? Let's see it with help of an example. If you write 10 less than 5, what value you are going to get is false, because 10 is not less than 5. So it's that simple to understand. Okay, likewise, if you write 5 greater than 6, I specified a space here, that's why it's not able to recognize statement. Yes, so 5 is not greater than 6, that's why again we are getting false. What about 6 less than 6? Again you are going to get the value false. But if you write 6 less than equal to 6, I have changed the operator here, so you are going to get the value true, because 6 is not less than 6 but it is equal to 6. So remember, this is less than or equal to, that's why equal to is true, you are getting the value true. Fine. The next relational operator is not equal to. So if you write 5 not equal to 5, what should you get? So you need to understand what are you checking here. Okay, so what you are checking here is whether 5 is not equal to 5. So what answer you are going to get? No, 5 is equal to 5, so you are going to get false here. I hope you understood. Okay, and similarly, if you say 5 not equal to 9, what is the answer? Yes, 5 is not equal to 9, so you are going to get the result as true. So this is how not equal to works. And lastly, the double equals to sign, which is also called as comparison operators sometimes. Okay, so when you check whether two values are equal to each other or not, you use this operator. So if you write 5 double equal to 5, or let's say for example 5 double equal to 10 floor division 2, what should be the output? Okay, of course this will be evaluated first, so what value you get here is 5, and then that 5 is compared with this 5, and both of these are equal to each other, that's why you get the result true. So you can write another example like 10 minus 5 equal to 50 minus 45. So what do you think about this? True. 10 minus 5 is 5, 50 minus 45 is 5, then 5 and 5 are compared. So in any case, if the values are not equal, like 6 equal to 3 modulus 2, what about this? Remember the modulus operator? It calculates remainder. So when you divide 3 with 2, what remainder you get is 1, and 1 is not equal to 6, hence the result is false. So this is how relational operators work. And of course you can apply them on variables if you want, it's not a big deal. If you write a is equal to 5 and b is equal to 10, you can simply use the variables with these relational operators, like a not equal to b. You're going to get true as a result, and you know the reason why. After relational operators, there is this third category called as assignment operator. Okay, and it is denoted by this equal to sign, and I guess you know it already. When you write a variable to left hand side of this operator and you're writing a value to the right hand side of this operator, then that value will be stored in the variable. It is very, very simple for you to understand. But the assignment operator can perform some interesting operations as well that we'll discuss. Let me show it to you in a new window here. Fine. So for example, if a variable a has the value 10 in it, and B also has the value 10. So you had to write two different statements for storing same value. You can use the assignment operator for doing this task in a way that this operation is performed in one line. How? So I'm changing the variable names here so that the thing is clear to you. So x is equal to y is equal to 50. Okay, so you have x and y as variables here and 50 as value here. So what it does is it stores 50 in both x and y. So this is how assignment can be useful in assigning single value or same value to multiple variables. So when you print x, you get 50. When you print y, you get 50. Now one other important feature of assignment operator is that it can be used to interchange values. Okay, so for example, if I have a variable p is equal to 10, q is equal to 20, and I want to write code that interchanges the value, that is the value of q is stored in p and the value of p is stored in q. So in other programming languages you might find it difficult to understand because you need to understand the logic first of interchanging, but in Python you can perform this type of operation very easily by using this assignment operator. So how do you do it? You simply write p comma q is equal to q comma p. I had given one extra space here, that's why it's not working. So let me write it again. P comma q is equal to q comma p. It works this time, and when you print p you get 20, q you get 10, and that's what you want. It's that simple. Okay, so what it does is actually whatever you write at the right hand side of the equal to sign, it assigns these multiple values one by one to the variables written at the left hand side of this operator one by one. Okay, and one more concept is playing a role here, that is called as tuple. So we are not going to discuss tuple right now because you won't understand that. So when we'll cover up tuple chapter in our upcoming videos, you will automatically understand the role of tuple in such type of statements. So for now you just remember that equal to sign is capable of interchanging values also. So that's it for assignment operator. And the next category of operators is called as logical operators, and they are and, or, not. We have three logical operators, and remember all three are keywords, hence they must be written in small letters. Okay, so just like relational operators, logical operators also compare to conditions, I would say. And just like relational operators, they too give result as true or false, that is in the form of a boolean value, which is either true or false. So relational operator was comparing two values, remember, and here we are comparing two conditions. So let's discuss this thing in detail with the help of example. And before going for example, let me clear the functionality of these operators. So talking about AND operator, you just have to remember it gives true only when both conditions are true. And about OR, remember, it gives false only when both conditions are false. For every other situation, in the case of AND, the result is going to be false, and for every other situation in OR, the result is going to be true. That is, when we talk about AND, if you have true, the first condition is true and the second condition is false, the result is going to be false because one of them becomes false. Fine. If you have first condition false and second condition true, then also you get the result false. And of course, you have both the condition false, you have to get false here. And the last combination, if the first condition is true and the second condition is also true, then you get true. So in order to get true with AND operator, you have to ensure that both the conditions are true. Talking about the OR operator, the situation is a little different. Let me copy this code here. Fine. So in case of OR, when the first condition is true but the second condition is false, what value you are going to get is true. Okay, so what have I written about OR? It gives false only when both conditions are false. If any of the conditions is true, the ultimate result is going to be true, and that's what we are writing here. So true or false is true, false or true is also going to be true, false or false is going to give you false. You know the reason. And if you write true or true, you have to get true. So I hope the functionality of these two operators is clear to you. Talking about the third logical operator, NOT, first of all, it is a unary operator that you remember, and it simply reverses the condition. That is, true will become false and false will become true. So this is the meaning of these three operators. Now let's see them with the help of examples. So the first is AND. So I'm going to write two conditions here. So for example, if I'm checking 3 greater than 4 and 5 equal to 5. Okay, so this is the statement. One thing for sure is I'm going to get either true or false here. So what do you people think? So first of all, this condition is evaluated, and then this condition is evaluated, and then the AND operator plays its role. So this condition is false, but this condition is true. So what do we have here is false and true. So what is going to be the result? False. So remember what I said about AND operator. If any of the conditions is false, the ultimate result is going to be false. Second example, if you write 5 not equal to 10 and 5 modulus 2 not equal to 0, what about this condition? Okay, so you have to evaluate this separately and this separately, and then you have to combine. So is 5 not equal to 10? Yes, 5 is not equal to 10, so you are going to get true here. And 5 modulus 2 not equal to 0? Yes, 5 modulus 2 is not equal to 0. So in both the conditions, what value you are getting is true. So it is true and true. So the result is going to be true. Okay, so I hope the concept of AND is clear to you. Now to understand OR operator, I'm going to use the same example. I'm just changing it to OR. Now what should happen? Again, this condition is evaluated first, then this, and then both will be combined with OR. So what is the property of OR? If any one condition becomes true, the ultimate result is true. Otherwise it is false. So 3 greater than 4 is false. So this condition is checked. 5 is equal to 5. Now this is true. So what do you get? False or true. So what should be the result? True, because one condition is true. Similarly, in the second example, if you write 5 not equal to 10 or 5 modulus 2 equal to 0. Okay, so I have made a change here. So the first condition is true, but the second condition is false. Fine. So even then, I have again given extra space here. See, so again you are going to get true as the result, and you know the reason why. Now talking about NOT operator, again I am going to use the same example, and before using this example, let me simplify things here. So if you write not true, okay, I'm so sorry, if you write not true, that means you are reversing true, or you're converting true into false. So what you're going to get is false. And if you are using not false, you're going to get true. So this is how not works. So if you use not operator with conditions like not 5 greater than 2, so it is evaluated as, first of all, this condition is evaluated separately and then not is applied on it. So what do you get here? 5 is greater than 2. Yes, 5 is greater than 2, which is true, and not true becomes false. Okay. So if you use it in more complex situations such as this, I'm going to put not here and not here. Fine. So what happens here? We have not operator and we have AND operator. Now remember, before I press enter key, you need to understand the priority among the logical operators. Okay, yes, there is a priority among logical operators. So if you have AND or NOT, all of them in a condition, or any two in a condition, first of all NOT will be evaluated. Okay, and let me correct it. First of all, bracket will be evaluated if bracket is there. So bracket gets the highest priority again. But if bracket is not there, then NOT will be evaluated first, then AND, and then OR. It's very important to remember this order or this priority among logical operators. So this is exactly what is going to happen here. First of all, this NOT will be evaluated. Okay, so not 3 greater than 4. That means, is 3 greater than 4? No, false. And not false is true. So what do you get here? True. And then here, not 5 equal to 5. So 5 equal to 5 gives you true, and not true is false. So here you are getting true and false. What is going to be the result? False. So I hope you have understood how we are going to use the logical operators in Python statements. Fine. Now there is one more operator called as membership operator. This is the next category. Okay, so we are done with logical operators. This is membership operators, and membership operators are in and not in. So these are the two membership operators, and as the name suggests, that it checks whether something is present in a value or not. Okay, so let's see it with the help of example. So if you have a string, for example Raj, okay, R-A-J, and if you write A, the character A, and then use the membership operator in S, okay, so what you are going to get here is either true or false, of course. Okay, this you remember, result is either true or false. Okay, so here we are checking whether this letter A is present in this string S or not. Since it is present, you are going to get the result true here. But if you use the letter X, for example, so you write X in S. So what are you doing here is you are checking whether the letter X is present in string S or not. So what value you are going to get here is false. So this is how membership operator works. Similarly, if you want to use not in, let me use not in here, you have to write not space in. So it is just opposite to in simple words. Okay, so what you are doing here is you are checking whether A is not present in S. So it is going to give you false because A is present in S. And in this example, if you write the same code but with not. Okay, so what you are checking here is whether X is not present in S. So X is not present in S, yes, so the result is going to be true. So this is how membership operator works. So this membership operator can be applied on various different objects in Python. Right now we are applying it on strings. Okay, remember what a string is. It's a collection of characters. So you can check for a single character among all the characters in the string by using this membership operator in. Okay, so we'll explore the usage of in our future videos. Fine. The next category that we need to discuss here is called as identity operator, and this is again going to give you the result in the form of true or false, and the symbol is, you write is. Okay, this is again a keyword. So is an identity operator, and one more is not. Remember, it is not is. Okay, often students they get confused in this. Here we had written not in, but you cannot write not is here. It will not make any sense. Fine, so it is not. So just like in, you have is, but instead of checking the presence of a value in another value, you do the complete different thing here with this identity operator. So it checks for equality in memory address of variables. Okay, I'll tell you what it actually means with the help of example. So I hope you remember in one of my videos I had explained you the identity function called as id. Okay, so for example, if I have a variable, let me do one thing, let me close this window, load it again. Fine, so if you have a variable a is equal to 10, you can check its memory location with this id function. So this is the location where I have value 10 is stored, and that location has a name A here. Fine. So this you already know. So what happens when you have another variable B and you store the same value in it? Okay, now you might understand this concept as this. Let me show you this with the help of example. So what happens in most of the other programming languages is when you write A is equal to 10, you have a memory block created. Okay, this is A. Suppose it has an address 6, 5 and 6. Fine. When you write B is equal to 10, you have another memory block whose name is B, and it will have some different memory location. And of course you have same values in both the memory blocks, but they are two different memory blocks inside the memory. So this is what happens in the other programming languages. This is not the case with Python. Okay, you remember in my earlier video I had explained you the immutable types. Okay, although this concept we did not discuss in that video, but if you have watched that video, you should understand what I'm going to explain right now very easily. So if you assign same value to different variables, okay, Python has a different approach for performing this operation. Okay, so let me show you what. Let me delete this thing. In fact, yes, so if I have a variable A in which I have a value 10, fine, and when you had written B is equal to 10, what Python does is it creates a variable B, and this B is also going to point to the same memory block, okay, where 10 is stored. So what should be the address of B? It has to be the same, 656. So you can say when you are assigning same value to two different variables, two memory blocks will not be created. There will only be one memory block where both the variables are pointing. This is what Python does. Okay, so if this concept is clear to you, then you can simply assume and tell if you print the address of B by using this id function, it should be same. It is same, as you can see, and this is the reason why. Now interestingly, what happens if you change the value of B? For example, I change it to value 50. Okay, so should this change be reflected in B as well, because they both were pointing to the same memory block? Well, it might seem correct, but it is not the case. B is still 10 and A is 50. So if you had understood the concept of immutable types, in which I explained in my previous video, you can simply understand this, why this is happening like this. Let me tell you. In fact, when you assign a different value to A, what happens is it simply gets deleted from this block. B is still pointing to this block, and when you assign a different value, a separate memory block for A is created where 50 is stored, and it will have a different memory address, for example this. So that's why there is no conflict between these two variables A and B when you assign different values. So in this case, when you check ID of A, it is showing its ID, and when you check the ID or the memory address of B, it is different. So I hope you have understood this very important concept. So now we can talk about the identity operators is and is not. Okay, since they are going to check the equality for memory addresses of two variables. So if the addresses are same, it should return true, and if they are not same, it returns false. So let us see. So here I have a variable A storing the value 10, B is also storing the value 10. Now we know that both these variables are pointing to the same memory block, and hence the addresses are same. So we can simply write A is B. Okay, A is B, and there should be a space before is and after is. So when you press enter key, it returns true. Why? Because the memory addresses are same. Both the variables are pointing to the same memory block. And if you change the value of A to 50, then if we check A is B, it is giving us false. Why? Because there has been a new memory created by variable A. It is no longer pointing to the memory block where B is currently pointing. So they both are separate memory blocks right now. Hence the address is not same, so it returns false. Likewise, you can check for is not. So let me use different variables now. X is equal to 10, Y is equal to 10. Now if we check X is not Y. So what are we checking here? Whether the memory address of X and Y are same or not. Okay, so it gives us false because they are same. Okay, and similarly, if you change the value of X to 50, for example, and now if you check this, okay, what are we checking here again? Whether X is not equal to Y. So in this case, yes should be the answer, because yes, the result, the address of X is not equal to Y. So that's why it gives us true. So that's it for this video. I hope you have understood all the concepts well. It has been a long video, but a very important one, I guess. If you have any queries regarding any of the topics discussed, you can ask me in the comment section below. And if you like the content, please comment, share and like, and do subscribe to my channel. Thank you.